coming to the next class, Newton's second law of motion. The Newton's second law of motion. Before discussing about Newton's second law of motion, first we need to discuss linear momentum. Right now here three vehicles are there. First you need to observe A vehicle, B vehicle, comparison. Here three glass plates I arranged. Okay. A car, which is a toy car, 500 grams, 10 meter per second. B car, which is of 500 grams, 1 meter per second. Those two are moving toward the glass plates. Then, which breaks the glass? You will observe that and you will say one answer. What is that? Means definitely you will say answer A. Okay. If your answer is A, you will compare 500 grams, here 10 meter per second, here 1 meter per second. You will compare. Here 10 meter per second is more, so that A car will break the glass. Definitely. Just it is right. And right now, comparing between A and C. Okay. Here this is moving with 10 meter per second. Here C car is also moving with 10 meter per second. And A car is 500 grams, C car is 100 grams only. Okay. And right now, which makes the damage? Definitely you will say your answer is right answer. What is that? Again, A car will break the glass. Why? What is the reason? Here 10 meter per second, here also 10 meter per second. Your comparison is matches. Here 500 grams, here this is 100 grams. So this is less, here it is more. So that A car will break the glass. Finally, A and B, and comparing with A and C. Okay. Why it is breaking the glass? Why these two are not breaking the glass? What is the reason behind of this? Here, in between these two comparison, speed, velocity is more. Here A and C comparison, mass is different. Here mass is more. Okay. Nothing but in two comparisons, one is velocity is more, and second comparison, mass is more. Nothing but if mass increases, it breaks the glass. If velocity increases, it breaks the glass. Nothing but which is having one quantity. By these two we are getting one quantity. Okay. The quantity of motion of the body is more for A. Comparing between A and C and A and B. Okay. The quantity of motion of a body is called linear momentum. Quantity of motion of the body. Quantity of motion of the body is called linear momentum. Okay. On what factor this linear momentum is depending? It is depending upon two factors. One is mass, second one is velocity. Okay. So that we will get a definition for linear momentum. The quantity of motion of the body is called linear momentum, and linear momentum is represented with the symbol P. And linear momentum is also defined as the product of mass and velocity. The product of mass and velocity. Okay. Here linear momentum is equals to, we can write a formula. Linear momentum is equals to mass of the body and velocity. We can represent mathematically. Linear momentum is P, mass is M, and velocity is V. So that we are getting a formula here. Velocity is a vector quantity and momentum is also a vector quantity. This is the mathematical expression for linear momentum. Okay. On basis of this, what is the unit of linear momentum in SI system? In SI system, linear momentum unit is kilogram meter per second. So we'll get kg meter per second. Okay. And one more unit also we'll get according to the definition, Newton second. I will give you. And similarly, CGS unit, gram centimeter per second. This is also takes as dyne second. And we can define linear momentum in another way. What is that? Means further class actually in Newton's second law of motion we will get one definition we have. What is the definition? I will give you one small idea about it. Linear momentum is giving you the product of force and short time interval. The product of force and time interval is called linear momentum. Product of force is Newton, time we are considering it as second. So we will get Newton second. CGS unit is dyne second. Okay. And after completing this, we have Newton's second law of motion. Okay. According to Newton's second law of motion, for example, you can consider a person is cycling. Okay. Heavier person or a fat person who is going on the cycle, he need to apply large amount of force. What happened? The change in velocity will be less. If a person is very lightweight, then what happened? He will apply. If he applies a large amount of force, his velocity will be changes rapidly with respect to less time. Okay, so that we'll get one definition for that according to Newton's second law of motion. Newton's second law of motion is giving you the relation between momentum, rate of change of momentum and force. Okay. According to Newton's second law of motion is giving you the rate of change of linear momentum is directly proportional to applied force. This is the definition of Newton's second law of motion. Okay.